let's take notes on our next lesson, which is lesson 103. 103 has 3 topics. So let's look at the first one first. 103, the first topic is powers of negative numbers. Now, there's 2 things that we can look at when we do powers of negative numbers, okay? Just as a reminder, if I have a positive number times a positive number, what's my answer? Positive, because we multiply, the answer is positive. If I have a negative number times a negative number, we multiply, and the answer is? If I have a positive times a negative, or a negative times a positive, the answer is? Going to be negative in both cases. So how does that now apply to negative numbers? Well, let's take a look at this real quick. Negative 2 to the 3rd power. The exponent means what? Negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is a positive 4 times negative 2 becomes negative 8. An odd number of negatives being multiplied is going to give me a negative number. If I had an even number of negatives, let's do negative 2 to the 4th power. It's the same thing, negative 2 times negative 2 times negative 2 times negative 2. And if we follow the steps, 4 times negative 2 times negative 2, negative 8 times negative 2, we get a positive 16. So an odd number of negative factors produces a negative product. Well, that's in life too. You look at life, negative. A lot of your things in your life are negative. Your life, the product, is going to be negative. Look at that. Here's your life lesson. But an even number, this one doesn't apply. Negative factors produces a positive product. I don't know how we can fit that one in life. So there's only one other thing to make sure we point out on this. There is a difference of something. Negative 2 cubed does not equal negative 2 cubed. Why might that be? Yeah. Why aren't those the same thing? No. There you're thinking to the negative 3. That's a negative power. Negative power is different. Yep.
Yes, but
that's all I'm asking.
you're cubing just the 2 and not the negative?
Yeah. Okay. We're going to write in red here. Exponents apply only to what is directly in front. So for example, if I had a b to the cubed, that is a times b. And I think we know that. We've discussed that. We're aware of that. So over here, what happens, this negative 2 is exactly what he said. This is a negative 2, 2, 2. Where over here, I get negative 2 times negative 2 times negative 2. Now what I want to show you is that in odd exponents, the answer might be the same, but the original is not. And we can see that now. Let's use negative 2 squared versus negative 2 squared. In this case, we get a negative 2 times 2, which is a negative 4. Here, we get negative 2 times negative 2, which is a positive 4. There will be times when you do your work that it's going to get the right answer even though you did it wrong. It's okay. You know how to do it right. Does that make sense? All right, so let's look at the second part of this lesson. Part 2 of this lesson is dividing terms. Part 2 of this lesson is dividing terms. Let's go back to 6th grade or even earlier this year, where we would reduce a large fraction. Let's say I have 128 over, let's say 56. Maybe we should flip that. Let's keep it improper, okay? One of the things we learned to do is we would do a factor tree, right? So if we factor tree this, 128, that becomes 4 and 32. 4 is 2 and 2. 32 would be 4 and 8. 2 and 2. 8 is 4 and 2. 2 and 2. That's a lot of 2's. Bottom of the tree, 2, 2, 2, 2, 2, 2, 2. That's 1, 2, 3, 4, 5, 6, 7 2's. 1, 2, 3, 4, 5, 6, 7 2's. Over 56. 8 times 7, 2 times 4, 2 times 2, bottom of the tree, 2, 2, 2, 7. And then how would we simplify that? Yeah, because we can cancel factors. So what we're going to do is we're going to cancel factors. 2 becomes 1, 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 2 becomes 1. 2 times 2 is 4, 4 is 16. This becomes 16 over 7. We'll just keep it improper right now. So we're going to take that principle that we've already known, and I think you could simplify this next one without me doing anything with you. Let's see what you get as your answer. 12 x cubed y z squared divided by 3x squared y. Underneath that, write down the simplified answer. Stand when you get it. Give it a shot. Underneath it, what do you think the simplified answer is? I like some of the work I'm seeing from some of you. Okay, so the answer becomes 4xz squared. Sit down, let me show you the y. If you don't have it, grab your blue pen. 12, if we factor 12, 12 becomes 4 times 3, which is 223, right? So 12 is 2 times 2 times 3. X cubed means I have 3 x's. Y is 1. Z squared is 2 z's. On the bottom, 3. X, X, Y. Cancels the 3 and the 3. What's left is 4. An x and an x, an x and an x, what's left is an x. Y and y cancel. I'm left with two z's, z squared. That's where that answer comes from. Now, can we potentially have numbers on the bottom? Yeah. If we had x cubed on the bottom and x squared on top, our answer would have been 4z squared over x, because that x would have been left on the bottom. Does that concept make sense? That's two concepts, 10 minutes. Let's do one more of those types of problems. I would encourage right now, make sure you do this part, where you're breaking them up so you can see what you can cancel, okay? So here is your next one. 10a cubed bc squared. 10a cubed bc squared divided by 8ab squared z. I'm sorry, 8b squared c. And let's add an a to this, ab squared c. That's the one we have. So 10a cubed bc squared over 8ab squared c. Write out the factors, cancel what cancels, see what you get as your answer. So if I write out all my factors, I get that. I'm going to use red just so we can see what cancels. This 2 and this 2 cancels. This A and this A cancels. This B and this B cancels. This C and this C cancels. There's no other pairs that I can pair up from top and bottom. So my final answer is 5a squared c, 5a squared c over 4. What'd you do? Near 100%. What'd you do wrong? Oh, you converted it, okay. We're having a B. Juliana makes a good point. She has 1 and 1/4. I could live with 1 and 1/4, but then what that does is it changes over here. We keep the fraction part, a squared c over b. Okay, I don't know what happened to your other b. Because there were 2 on the bottom, 1 on top, so we can't get rid of the b completely. Does that make sense? So you can cancel, get it fixed. Get it fixed. All right, have a seat. So that's step 2. We did much better. That's second step of this lesson. Third step of this lesson is square roots of terms. Okay? And we're going to call these terms monomials. So we're going to do the square root of monomials. Okay. If you remember back to when we started with square roots, we would break them up into pairs. So let's go with 4. The square root of 4 was the square root of 2 times 2. Because there's a pair of them, we can pull that out, that's 2. Just a special note, remember this is 2 squared, right? But if we have the square root of 8, the square root of 8 was 2 times 2 times 2. I can pull out a pair, but I'm left with 1 on the inside. So 2 cubed. What rule can you tell me about exponents and square root? It's going to be a perfect square if what? Perfect square, not a perfect square.
If it's an even exponent.
If the exponents are even. That's exactly it. So let's make a ridiculous one. Let's take 16, a to the 4th, b to the 6th. Let's just go with that. Now, if I look at that, I get, okay, 16. I know the square root of 16. What's the square root of 16? 4. But let's write this out. Just for the purposes today, we got 2 times 2 times 2 times 2 times a times a times a times a times b times b times b times b times b times b. Now, if we look at what can come out, a pair and a pair, so that's 2 times 2. Those pairs come out. A pair of A's, so 2 A's come out. A B and a B and a B, 3 B's come out. So 4a squared b cubed becomes my answer. What's my relationship between this and this? What can you tell me specifically about the exponents, Elena? They cut in half. So rather than having to write out all of this stuff, we cut those even exponents in half. Does that make sense? So if we took one, let's not even use numbers this time. Let's just use letters. If I had b to the 100th, c to the 50th, and I want the square root of that, we have an option of A, writing out 100 b's and 50 c's and counting all of our pairs, or we do what Elena says, we just cut it in half. What would be the square root of 100 b's and 50 c's? B to the 50, C to the 25. That's it. That's it. Okay? An even exponent indicates a perfect square. An even exponent indicates a perfect square. So, if I write down 3 options, 8, x squared y to the 4th, 16, x cubed y to the 4th, and 16, x squared y to the 4th, which one of those has a perfect square? Libby? Yeah, this is the only perfect square. Perfect square. So the square root of 16x squared y to the 4th becomes, what's the square root of 16? Square root of x squared is? Y square root of y to the 4th is? Y squared. That becomes the square root. What's wrong with the first one? Why does the first one not work? Yeah, 8 is not a perfect square. $16? I'm sorry, the next one? What's wrong with that one? Yeah. X cubed is not a perfect square. That's a lot of info. So what we're gonna do, we're just gonna do the first set of practice problems. I'm gonna do the first column. We're gonna save the other ones for tomorrow. All right, so I'm gonna write down A first. A is -5 times -4 times -3 times -2 times -1. -5 times -4 times -3 times -2 times -1. First thing I'm gonna do is I'm gonna look at my factors. I have 1, 2, 3, 4, 5 factors that are all negative. Is my answer gonna be positive or negative? Negative. 20. Negative 60. 120. Negative 120. Now, because it's commutative property, we didn't have to go one step at a time. We could have multiplied more numbers together. But that's order of operations. That's what we got. Let's look at C. C is going to be a -2 cubed. If we write that out, parentheses, -2 times -2 times -2. I like using parentheses with these. What's -2 times -2? So 4 times -2? -8. And negative makes sense because we have that 3. Which takes us to E. -9 squared. It's going to be an even number of negatives, so the answer is positive. What's -9 squared? 81. -9 times -9. G. 6a squared b cubed c. 6a squared b cubed c all over 3ab. A, B, 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 C, 3AB. 3 cancels with 6 and gives me 2. 1A cancels, 1B cancels, nothing left on the bottom. 2AB squared C is left on the top. I want you to do I. I is 15mn squared p divided by 25m squared n squared. Go ahead and simplify that one. In the first one, I didn't factor the first numbers. I just did it when I canceled, like you cancel fractions. We could do the same thing here. We don't have to factor it. But when the numbers get bigger and bigger, the factoring does help. I look here. I cancel what I can. 5 and 5 cancels. M and M cancel. N cancel. On the top, only a 3p remained. On the bottom, only a 5m remained. 3p over 5m. Perfect. Two more practice problems we got. Two more practice problems we've got. The two practice problems would be J, 12x squared y to the 4th. Didn't tell you what to do with it yet. And L, x to the 6th y squared. For J and L, I want you to say whether or not it is a perfect square. If it is a perfect square, find the square root of it. If it is not a perfect square, all you need is not a perfect square. 2 problems, go. A lot of information in one lesson. Which one's a perfect square? J or L? L. So that means this one is not a perfect square. We have an even and we have an even, but this is not a perfect square. So we would say not a perfect square. Because this one is, what is the square root of it? X cubed y. Cut the exponent in half. That's it. Have a seat.